Let's consider a problem dealing with friction. So, it's wintertime, you're going backpacking. Oftentimes when you go backpacking in the wintertime, you put your gear on a sled. So we have gear and sled that have a total mass of 18.2 kilograms, and you apply a force of 140 newtons along a rope that is connected to the sled at an angle of 17 degrees above the level ground. So let's list out what we know first of all. So we know that the mass is 18.2 kilograms. And that you are applying a force of 140 newtons at 17 degrees above the level ground. And we have a coefficient of friction of 0.12. So the first thing we want to calculate is the magnitude of that frictional force. So we already know the coefficient, so I'm going to look at using the frictional formula directly. Force of friction equals mu times the normal. We know mu, 0.12, but we need to calculate the normal force. Okay, so let's draw a free body diagram and see what we have going on. Here's our sled, and we have a force there of 140 newtons, 17 degrees. The sled is supported by the ground, and then it also has a field force of the weight, and then there is a frictional force. What we need is to calculate the normal force, and the normal force is a vertical force. So the first thing I'm going to do to get that is to find our components of the 140 newtons, because we have a situation of equilibrium vertically, and if we're going to set up an equation to be able to find that normal force, we're going to need at least this vertical component. So then x component, y component, cosine 17 degrees will give me x over 140. Sine of 17 degrees is going to give me y over 140 newtons. So then our values on those two forces, our x component 133.88 newtons, and our y component 40.93 newtons. Now we can set up our equation to be able to calculate what that vertical or what that normal force is. We have 1, 2, 3 forces vertically, remembering that weight is equal to mass times gravity. So then, as I carve out some space here, as we set up the vertical equation, that'll be positive F sub n, because it's upward, positive 40.93 newtons, also upward, minus the weight, which is mg, 18.2 kilograms times 9.8. And we have an equilibrium vertically, so that's equal to 0. There is a 0 just off the screen there. So when we solve that force down for our or that equation down for our normal, we get a normal force value of 137.43 newtons. Now we can bring that back over here and multiply that by the coefficient to get the frictional force. So 0.12 multiplied by 137.43 newtons, that'll give us a frictional force value of 16.49 newtons. Now, we were able to do that directly because we already had the coefficient. Sometimes when you're calculating the frictional force, you have to go through a Newton's second law equation instead. It really just depends on what's given. Now, looking at part B, determine if the sled is accelerating or if it's traveling at a constant velocity. Well, if we look at the forces we have here, our frictional force, 16.49 newtons, and then the only other horizontal force we have is right there, 133. we definitely have extra newtons to the right. And if we have extra newtons, that means we're going to have an acceleration. So it is accelerating. Now let's calculate that acceleration in part B. So we can immediately say accelerating. To be able to calculate that, Newton's second law horizontally, net force is equal to mass times acceleration. This means set up an equation, find the extra newtons. So this is going to be a positive 133.88 newtons combined with a negative 16.49 newtons equals mass times acceleration. Mass is 18.2 kilograms, and then times A. And then do the algebra, combine your forces, divide by your 18.2 to be able to calculate what that acceleration is. Solving that down, we get an acceleration of 6.45 meters per second squared. And that's going to be in a forward direction. So even though in problem solving like this one doesn't ask you to draw a free body diagram, to be able to understand the forces and find some of the different forces, you have to draw a free body diagram to then facilitate setting up and solving down the equations. Ponder physics.